Hello, welcome to Connection Wednesdays. This is Uri and Adam from IDEA StatiCa. This is another webinar on our solutions today about what we can do in cloud. Hope you can hear me and also see us. A good day to all of you. There is my colleague Adam, product engineer. And change of plans, there was supposed to be Jana, our other product engineer, but she's not available today. So I jumped into her shoes and we'll talk today together with Adam about what we can do in the cloud. We are using GoToWebinar. You are all by default muted to keep the audio clean. Please enter all the questions on the right in the ribbon. You can also edit your audio settings there, and we'll be covering the questions continuously, and some of them at the end. Hopefully we can cover all of them. And today is about meeting our cloud solutions. I'm gonna go from the actual PowerPoint to our website. You know it, ideastatica.com, and on the top ribbon, apart from steel, concrete, BIM, there is this mysterious word cloud. And under that, we have three online apps: Connection Lite, Effectivity Calculator, and the Project Viewer. So the Connection Lite, that's a simplified version of our full IDEA StatiCa connection desktop app, which works with predefined connections. Hundreds of predefined connections you can do here in a few clicks. Adam will show it. Then the Effectivity Calculator, that is a tool to actually evaluate how the processes related to connection design in your company are or are not effective, and how can IDEA StatiCa help you. I will show that personally. And we also have our famous Project Viewer, which is the way to share your work, to share and open any IDEA StatiCa project instantly. Anybody can do that. Great for collaboration. So we got three tools we'll be working with, and we can start it off with the Connection Lite. Adam, will you show us?
Of course. Thanks for the words, Uri, and welcome again, everybody. Let's just take the presenter and just check the screen. Everything looks okay. So let's get started with the cloud applications. Let's just jump into Connection Lite application. That's the Lite version of our desktop connection application. So let's get started. This is the starting web page. What we can see here, some pictures of the topologies of the templates. What to discuss here on this first page is settings, of course. You can change the language here and change the unit system. So I'll stick with English and metric one, and of course choose the code. Here we provide Eurocode and American code. So I'll go with the Eurocode. And there's the menu here where you can open existing project and save it, new, etc. I'll discuss that a bit later. So let's get started with one example that I prepared for you. That will be a frame joint. So I'll select here this first topology. That's the closest one to the frame joint. It's all described in the text below the picture as well. So I'll pick this one. And here we have some options. We can change topology, add some stiffeners, change the connection type, etc. And here on the left side is the 3D window where we can take a look at the model and rotate and everything, just as we are used to in the desktop application. So basically, we have here a few steps to go through. First, we define the topology or the configuration of the joint. So I'll choose the beam to column double-sided, so to have the real frame joint inside of any steel construction, for example. So next, we can change the steel grade. I'll stick with 235 steel quality, and we can change the beam angles here as well, something like that. So I'll just leave the 0 degrees. Here's the summary, Eurocode, units in millimeters and degrees. So in the next step, we can change the orientation of the column and the column shape, if it's a I shape or open shape of the cross section or closed one. So we can change that here. For example, if I change to RHS, or just switch back. So another configuration, and here we change the actual cross sections of the members. So for the column, I will go for HEA 400, this one. And for the connected members, it will be HEB 260. Right. This is defined, and the third steps, we can attach some stiffeners. There's the whole variety of the stiffeners that are being done. So just clicking on that, we add some more. I'll choose another stiffener for the haunch and a stiffener on the members related to the haunch as well. So something like that. And here we can configure or modify the stiffener stiffness. So I'll go for 8 millimeters. That's for all the stiffeners, all these 3 on the column and the 2 on the members. So as you can see, this is somehow simplified design. And for the haunch, I'll change the size and thickness as well. So these are the haunch stiffeners. So for the welds, I'll just leave the default weld size. If we click on the weld on the 3D window, we can read the thickness of 4 millimeters, which is fine for me. Of course, it's automatically calculated based on the connected plate thicknesses. So, last step here, we switch between welded and bolted connection types. I'll go for bolted, and here I'll change the thickness of the end plate to 12 millimeters, change the offsets, 180 on the top and the bottom, looks like this, and of course change the bolt size and grade, M12, and I will now define the bolt positions. All right, 50, 50, and 40, 50, 50, like that. Let's see the result in the 3D window. It takes a second, and the server refreshes the display. So we got that all in position. I consider this joint to be designed. Just to comment, this is the display or display of the bolts, how you can define its position. That helps you define these numbers here, and you can turn off and on the symmetries here. So it's another option. I'll continue to the next step. That's the check. Here we define the forces. So I'll input them by hand. Shear force and the moments. All right. Again, they are displayed in the 3D window, just basically to visually check they are in the place. Right, here we have the summary of our design, which we can also change here, because now I'll just click calculate. The analysis, which is based on the exactly same analysis score as our desktop application. So it's the CBFM analysis, component-based finite element method. Exactly same calculation, exactly same results as in the desktop application. And this is now for free. So good news. And here, as I said, we've got the results. You can also go through or take a look at the model and click on the items to highlight its properties. And here on the bottom left part of the screen is the analysis results, just the overview. And if we would like to change anything, for example, stiffen the thickness, or I don't know, anything that just didn't pass the check and I would like to modify, I don't have to jump back and to the last step and back here to calculate, or just simply modify it here and recalculate in a second. So that's for the analysis. And the last step, of course, is the report. Here, as a default, we get the basic summary, just about provides the information that you saw in the last step, just the picture and overall results. Here we can, of course, modify the name of the project and other information, author, description. Jana is missing. And if you'd like to get the detailed report, the one that we are used to in the desktop application, we just switch here. And we can hear some proposals, but the important information is that it's still in the beta period, so it's all for free. And it's going to stay that for a couple of months at least. And the only thing you have to do is to sign in for free. So I'll do that now. And you can create account, of course, as just normal way, or sign in with your Google account, where you can share your projects through your Google Drive and etc. So I'll just sign in as a IDEA StatiCa user and refresh the detailed report. And that takes, of course, a couple of seconds now. We're waiting for the server to connect to the information request and get the response. And we'll see exactly the same report with all the details, pictures, all the code checks, all the values, everything there. Yeah, and then we can of course add some more stuff if you like, theoretical background, drawings, etc. And then refresh. And how to get that or to send anybody, print to PDF or on paper, just the normal way. So print to PDF is the option. And the last thing what I would comment here is that we can save the project. So I'll do that. And let's say project 1. And we save that as a simple file, project 1 dot con with 2 n's, which is a different format from the desktop application. So if you save this one here, you cannot open that in the desktop application, but you can send the simple file to anybody, your colleague, partner, anybody who would like to take a look online at the project, and he just opens the file. I can show you that. If I'll sign out, and I'll open the project from my desktop, and it's all defined here with all the forces. Of course, it's not calculated. Yeah, so just the simple way. And now I will let this calculate here and show you this exact joint in the desktop application, so you can compare the workflows and also compare the results. As I promised you, they'll be the same. So in the desktop, I'll start the project as usual. So I'll pick some starting topology, something like that. The steel grade is fine, Euro code, everything okay. So let's create the project. Again, just wait for my computer to do that. And I've got it here. So what I will do, let's start, for example, with the load effects, since I jumped in on the load effect tab. So I will fill that in here, the same values as in the cloud application. If you still remember them, I don't, but I'll show you that it is the same in a minute. All right, then let's change the cross sections. So we can do that just right-clicking on the column, click on the plus icon here, and add new cross section. That was EHB 400. I can just check it here, EHA 400, yes. So let's pick that one. And for the members here, for the beams, of course, we can do the same, or we can also, the other option to change cross section is here in the menu. So I'll do that from here to show you another option. That was 260, right? EHB. And for the other one, let's try again, right click, and from the menu, since I already added this cross section to the actual library of the project, I can just pick this one. Right, that's for the geometry, and now I'll modify the end plate operation. So what we have here, it's set for both beams, B1, B2, connected to column. So I'll leave thickness of 12 millimeters, since that is the thickness I used for in the cloud application. Change to provide symmetrical. Modify the size of the end plate. Change the bolt size. Modify the position of the bolt and left layers. Oops, I'm missing minus here. All right, so it's looking exactly the same as in the cloud application. So I'll just continue with stiffness here. Just check. As I remember, they were of 8 millimeters of thickness, so that's fine. Here was 0, which was 4 millimeters. Can compare that. So 4 millimeters, I would like to input here just for sure. And what next? I will modify the wideness here. So this will be of 8 millimeters, size of 180 to 200, and shape of triangle. All right, the same one here. Or if I don't want to struggle with that, I can also delete this one, copy this one, and just show to which member and plate it is connected, and that's it, because I just love the copy feature. And the last one, I will add one more stiffener, or two more stiffeners actually, one more for the column. So I'll do it like that, 8 millimeters, and here it's related to B1, just the lower one, and I will shift this 180. All right, it's in position again, 4 millimeters, and more stiffeners. I can do it like this on right click, modify. So I'll add now another stiffener to the beam, and of course change some parameters here. Position of 200, good, and of course copy for B2. So that's it. Let's calculate that and see about the results. Well, if I would compare the workflows, I think you noticed that in the cloud application online, it's somehow faster, somehow more simple. It's actually like a game, like a computer game. You just run through in a minute and get the job done. In the desktop, it's pretty fast as well, I would say. But of course, here you have much more options. Everything is absolutely open for editing, modifying. You can do everything here in the desktop, so it takes a couple more seconds or minutes to get the joint done, the design done. But of course, it provides much more features. So about the results, of course, in the desktop version, we can go through the check tab and take a look, for example, on the stress distribution along the joint. Check the the mesh and the deformed shape of the joint. So again, desktop version provides more information. If I turn on the bolt forces and click on one of the arrows, that shows me the magnitude of the tension force in the bolt. I can see that in the tab here, open and go through the formulas of the code, see all the numbers listed here. So as I said, more options in the desktop, and the report that is the same as in the cloud application. So I'll just wait for that, for the generation. And to show you, I'll just jump back to results and somehow make this visible like this, and we can compare the results here, the overall and the overhaul here, and the desktop. You can see they're just the same, just a one instead of two here, but that's just because of the mesh generation. All right, so I'll jump back to our online cloud applications. If I'll go for a new project, just to show you the other topologies, we've got hollow sections, column bases, beam splices, pretty much covers all the standard topologies, all the standard designs of joints. So I think it's pretty useful toy for any engineer to play with, and anytime ready everywhere for you, even from your mobile device and anything. So valuable tool for free for you. I'll close this now and continue with the project viewer. And one more thing here, I forgot. If you have a joint like this and you would like to get it displayed in your AutoCAD or Tekla CAD software, you can simply export the joint to 3D DVG like this. Again, just a couple of seconds when the server prepares the DVG file. And I can name it like test1, for example, and it just saves the 3D DVG. I'll show you that in my AutoCAD application to open the model in a minute, because from the viewer, because there's the same feature. So I'll now go to Project Viewer and show you this tool that is completely and forever for free. And this is a tool for actually inspecting or taking a look on the joint which was created from your desktop application of IDEA StatiCa connection. So let me now save this one. And as a frame joint, for example. So this is now on my computer. So here I will load the frame joint model to the connection viewer. And this basically serves as a viewing tool. So if you create a joint, you can send it to anybody and he can just go to our web page, load the joint file. Doesn't have to own or have installed the desktop application, and just to take a look at the joint. As a 3D model, you can click on any plate to get the dimensions and the shape. This, you can click on the bolt to get the information of the bolt grade and bolt size. My window just got stuck now. So yeah, my computer is protesting. So this is for the bolt grid. You see the information, of course, the same for welds, thickness and material. Or I can, here on the left side, go through them each by each to get them displayed and highlighted in the 3D scene as well. Cool, so simple but pretty useful thing. Of course, we have some settings. We can change the metric system and open another project. And here, the most important, I would say, this button. Again, this creates the 3D DVG file, the model of the joint. So let's name it frame joint 1 DVG file. The same tool as in the connection Lite application I just showed you 2 minutes ago. I basically exported this joint model to 3D DVG. And now I'll jump to AutoCAD and open this frame joint 1 file. Let's do that. And so what we got here, we've got here all the plates exported as a 2D drawings and the 3D joint, as you can see here, right? But there is one thing, and that's actually today's HelpDesk highlight. There is a bug inside of AutoCAD or Autodesk applications, which the buddies from Autodesk are working on already. I've got all that reported. Since they load any DVG created from third-party softwares, they have this bug with the wrong display of the joint. But they provide a simple workaround until they get it all fixed. So if you, for example, change the view to conceptual, again, it's wrong. If you change to 2D wireframe, that usually shows you the real shape of the joint or the truth. During the rotation, it changes again. But if I'll go back to the realistic display, the workaround looks like this. You type the command audit, press enter, answer yes to fix all the errors, and voila, the joint is there in the shape as we designed it. So we've got the 3D model of the joint. What is missing here is the bolts, welds, anchors, and possibly the concrete block of the foundation. But still, all the geometry data is here, and we can work with that, add it to our 3D model of the structure, etc. So that's, I believe, all from my side for now. We went through the cloud application collection Lite, useful tool, and project viewer, another useful tool, both for free for you to try out. And I'll give words to Juraj to show you the third one, Effectivity Calculator, more related to the sales.
Thanks a lot, Adam. Thanks a lot for showing us how the online apps work. Before we go into questions, I see them popping up. Let me quickly show you the Effectivity Calculator. This is about how the whole connection design process is or is not effective. Imagine you are thinking about it yourself, or you're discussing with a friend what they do, what is their approach. So I've actually gone right into the Effectivity Calculator, and I'm an engineering company, and I ask myself, how many of my connections are simple, moderate, or complex? So let's say we are doing 60% of the simple stuff. Yeah, 20% is the moderate, and we do have the also the complex connections in our work. That's just plain numbers, 60, 20, 20. I click next. And I should think about how long does it take me or take us, how long does it take our organization to design and code check these connections? That means preliminary design, full code check according to whether it is AISC, Eurocode, CISC, Australian code, provide the reports, all the materials to prove to the authorities that this is buildable. How long does it take? For simple connections, yeah, we can do them in 7 minutes, right? Come on. For the moderate ones, that may be pain in the ass, so let's go with 30. And with the complex, that's tough. So around 200 minutes at least. Okay, that's how we work today. Next step, what does our office look like? There's actually 10 engineers, but only 3 of them do the connection design. They know the templates, they know the stuff. How much of their time they actually spend on it today? Roughly a third, let's say. So they work with the project as a whole. They spend a lot of time in SAP 2000 or Tekla. So let's say 30% of their time on the actual connection design. What's the cost of their time? What, as a company, we spend on engineering works? What's our price? What's our cost? So let's say something about 80, either euros or bucks. You can, it's very similar. So let's say our office looks like that. What do we use? We are doing a lot of Tekla work. We have SAP for the analysis, or I can specify something else. And we currently use Excel spreadsheet for our connection design work. We have the examples, the templates. All right, I click on next. It goes crunching the numbers, gives me the summary first. So 60% of our joins are simple, take 7 minutes per piece. Moderate, 20%, 30 minutes per piece. There's 3 of us. So when we crunch all of this together, we can make a proposition. So imagine you implement 2 licenses of IDEA StatiCa in the network configuration. What does it do monthly? Today, we spend 87 hours on simple joins. With IDEA StatiCa, this goes down to 46. We spend 29 hours on the moderate, it goes down to 13. For complex, 29 to 6. We are able to save 82 hours per month, which amounts to roughly 6,000 euros or bucks a month. So roughly speaking, we can justify and repay implementation of IDEA StatiCa in 2 to 3 months. I can export it as a PDF, send it to my colleagues, launch the discussion, and people will come and say, hey, we need to adjust the numbers because the simple is really 5, but the complex, yes, we have more complex. We have 30% complex. We have 10% only of the moderate ones. or 11, and then we really and we have much more time in that, in the complex ones. So that's just for the discussion how to how that can work. And as a result, it's all about to discuss the processes and find the savings. And this tool is there to facilitate that discussion. Okay. All right, let's look at some of the questions. Can we export the DVG file also from the desktop or only from the cloud, Adam?
Yeah, right. That's a good question. For now, from the desktop application, we can export only a DXF file of the bill of material. That means the 2D drawings of the plates with dimensions, position of bolts, etc., but not the 3D DVG model itself. For that, we have to use the project viewer, actually. That's the tool how to make it work. And in the future, this will be developed for sure as well, to export directly the 3D model from the desktop as well.
Okay, thank you, Adam. How can we check the equilibrium in the cloud application? Because we can do that in the desktop. How is it done in the cloud app, in the connection Lite?
Sorry, I missed the how can we view?
How can we check the equilibrium in the cloud application?
The equilibrium. Yes, that's a good question actually. In the desktop application, there's the equilibrium check button on the ribbon, which you should always have turned on. And it shows you whether your forces, your nodal forces of the joint are in equilibrium. So if you haven't done any mistake in putting the forces on the members. This is not in the cloud connection Lite. There is the equilibrium always turned off, just to keep it simple. So always double check your forces input if you play with the cloud application. Right?
Okay. Can we also have an estimation of the connection weight at the actual end of the process in the future? That's an intriguing question to kind of explore not just the time savings but also the material ones. We are collecting data from our customers to facilitate this. It's definitely somewhere down the line. The best thing you can help us to do that is to share typical examples, and then we can figure it out together. Okay, I think that's pretty much it. We'll go through the questions again, and if we missed something, we'll answer that via email. When the webinar ends, please be so kind and fill out a short survey. We will produce a recording of this, share it in the webinar section of our website and on the YouTube. You can get the trial of both the cloud and the desktop apps on the website, and you can find lots of documentation in the resource center regarding both. And we will be looking forward to seeing you at our next webinars. Actually, there's a Connection Wednesday in 2 weeks focused on buckling, okay, various aspects on how we deal with buckling in simple as well as complex steel connections and joints. And then April 17, release webinar about IDEA StatiCa version 10, both for steel and concrete. Thanks again for joining us. Have a good day, and bye-bye.
Bye. Have a nice day.